here is a review of all of our different methods for factoring so that you can get a little bit of practice. The first is greatest common factor, and so we're going to be focusing in this video on this particular strategy on how to take out a greatest common factor. So we're going to look at these first two, 16x squared and 6, and decide what common factor they have that I can divide out. And so I think that they're both divisible by 2. So remember that you have to place that greatest common factor in the front. I've divided out a factor of 2. And then you're going to go ahead and in the parentheses put what's left. So 16 divided by 2 leaves me with 8. I'm not taking out any x's since the 6 didn't have an x to give, so the x squared will remain unchanged. And then negative 6 divided by 2 is negative 3. And then there are 2 terms left, so I would need to look at those and decide, are they the difference of 2 perfect squares? And if they are, then I would need to factor them down further. But 3 is not a perfect square, which means nothing else can be done with this binomial and you're finished. This would be your answer. Those 2 factors would multiply together to give me 16x squared minus 6. Okay, let's look at the second example. Again, what can be removed from these 2 monomials evenly, and that would be a 5. So again, I'm showing that I'm dividing out a 5, and I'm going to make sure to place that 5 down in the front. And then in the parentheses, I'm going to put what's left. Anything divided by itself is 1. So I'm just left with m plus 10 divided by 5 is 2. Again, this is not the difference of 2 perfect squares, so there's nothing else I can do. There's my answer. Okay, so greatest common factor. Remember, you don't just always take out numbers, you can also take out letters. So, for example, if I had 2x squared plus 4x, I could actually remove from both of them a 2, but I could also remove an x from both of them. And so, like we were doing over here and over here, I'm going to place that common factor on the outside. That's my greatest common factor. 2 divided by 2 is 1. I had x squared, so I had 2 x's, and I took 1 away, leaves me with 1. 4 divided by 2 is 2, and anything divided by itself is 1. So there, I'm left with 2x times x plus 2. So you can take out letters as well as numbers. All right, let's talk about the difference of 2 perfect squares. So D2S, remember this from our list, we used GCF. We always start here, always. So is there a greatest common factor I can take out? That's where I'm going to start. And then from there I finish using some of these other strategies. I'm going to look at these 2. Is there a greatest common factor I can remove from both? The answer is no. So now I look at it and decide there's 2 terms here, so it must be the difference of 2 perfect squares. And if it's not, then it's nothing at all and it can't be factored. So is x squared a perfect square? Yes. X times x. And is 81 a perfect square? Yes. 9 times 9. So these are perfect squares because it's some number squared to get this answer. And how you break it down, if you remember, is that when you are foiling, the first term comes from multiplying the first 2 things together. So x times x. The last term, the constant term, comes from multiplying the 2 last things together, 9 times 9. What you'll notice about this FOIL is that you have first and you have last, but the O and the I term in the middle is missing, which means in order for them to be missing, they would have had to cancel each other out. So that means that outside, 9 times x needs to be negative, and 9 plus x on the inside needs to be positive, and that way the O and the I part will cancel out. Okay? So you do the first term, x times x, the last term, 9 times 9, 1 is positive, 1 is negative. And if I wanted to check, I could FOIL it out to see if I'm actually going to get x squared minus 81. So if I FOILed, I would get x squared minus 9x plus 9x minus 81, and you see that the 2 middle terms cancel and you get x squared minus 81. So it does work. This is how you break down the difference of 2 perfect squares, okay? So I'm not going to do all of this out every time I was proving to you that this is how you break it out. First, x times x, last, 9 times 9, 1 is positive, 1 is negative. Okay, let's look at the second example. Again, remembering that I always start with, do I have a GCF? I'm going to ask myself, is there something I can remove from both of these evenly? And the answer is yes. They're both divisible by 4. So again, don't forget to put the 4 out into the front. 4 divided by 4 is 1. Leaves me with x squared. And 100 divided by 4 is 25. So normally with these ones, there was nothing more that I could do with what was in the parentheses. But in this case, now that I've taken out a greatest common factor, I'm left with the difference of two perfect squares, x times x and 5 times 5. So I'm going to break down my difference of two squares using the pattern that I discovered in this first problem. X times x is how I got x squared, and 5 times 5 is how I got 25, and I know that one must be positive and one must be negative in order for me to lose that middle term. So 3 factors in this problem. Okay, so difference of two squares. Sometimes they will not have a greatest common factor and you just break them up, and sometimes they will have a greatest common factor that you just kind of drag along in the front and then break up the difference of two squares afterward. Okay, now we're going to look at trinomials where a equals 1. I'm just going to clear the screen and scroll the page up, and then we're going to go ahead and talk about the two different kinds of trinomials. A equals 1 and a is greater than 1. So a equals 1. These were the ones that we liked, we thought were really easy. You take the factors of the last term, so all the different factor pairs of 21, 1 and 21, 3 and 7, and that's about it for 1 and 21, right? So you've listed all the factors. Now your question is, how do you get this positive 10 in the middle? So positive 3 and positive 7 gives me positive 10. So I'm going to use these two factors, and since a equals 1, all you have to do is put them in the parentheses with your x terms. So x plus 3 and x plus 7. There's nothing else to do with the a equals 1 trinomials. You guys were really good with these factors of the last term that give you the middle term, and just put them right into the parentheses. Let's use the same strategy and do this one. Factors of 27. 1 and 27. Okay. 3 times 9. And what else? Anything? Probably not. Doesn't matter because I have positive 6. So I have a positive 9 minus 3. That's going to give me positive 6. Again, I don't have to worry about anything else. I found the two factors that give me the 6. Put them right into the parentheses. X minus 3, x plus 9. There are the two factors that give me that trinomial. Okay, so those are how you factor out the trinomials where a equals 1. And when I say a equals 1, I mean this term in the front. Remember that trinomials are ax squared plus bx plus c in standard form. So I'm saying if this coefficient in front of my x squared term is a 1, so this is a 1, and this one's also a 1. So these are a equals 1 trinomials. The next two trinomials are a is greater than 1. This time a is 6 in this one, and a is 3 in this one. Okay, so there's a lot more work to be done. These will be the hardest ones for you to do. These were the ones that we really disliked, but after you do a few of them, it becomes slightly easier. Since there is a factor in the front greater than 1, we can't just go ahead and do factors of 8 that give me 22. First of all, there are not going to be any factors of that last number that give you the middle term because you haven't taken into consideration the 6 in the front. So we have to take that into consideration, and we do 6 times 8, and that gives me 48. And I do the factors of 48. 1 and 48. 2 and 24. I don't even need to keep going down my list because 2 and 24 is how I'm going to get negative 22. Okay, now unlike where a equals 1, I'm not just going to say x plus 2 and x minus 24 because if I FOIL it out, there's no way for me to get a 6 in the front. So instead, I'm going to use these two factors that I've discovered give me negative 22, and I'm going to replace that negative 22 with those two factors. So the 6x squared stays the same, as does the negative 8. So 6x squared plus 2x minus 24x minus 8. Now I have 4 terms because I've split up this middle term into 2. And I'm going to take the first 2 and I'm going to decide what's the greatest common factor between these two. We've already done greatest common factors, so we can do this. They're both divisible by 2x. So don't forget the 2x goes in the front, that greatest common factor. 6 divided by 2 is 3. You had 2, you took 1 away, leaves you with 1. And 2x divided by 2x is 1. Anything divided by itself is 1. Now remember, our goal when we're doing this strategy of grouping, where we group the first 2 together, take out a greatest common factor, group the second 2 together, and take out a greatest common factor. Okay, this is tricky because I want the 2 parentheses to be equal. So I want this to say 3x plus 1. And so what would I divide these by? What's the greatest common factor? It's 8. Okay. But you'll notice if I do negative 24 divided by 8, I get negative 3x. And if I do negative 8 divided by positive 8, I get negative 1. So in order to change those both to positives, I need to divide by negative 8. So that's my greatest common factor, negative 8. And then I get 3x plus 1. Anything divided by itself is 1, so I get a 1 right here. And the great news about this is that this term and this term, remember we separate terms by addition and subtraction symbols, both have the identical same factor, 3x plus 1. So I'm essentially going to be dividing out a 3x plus 1 from both factors. Again, the greatest common factor goes in the front, 3x plus 1, and then in the parentheses you tell what's left. So if I divided this out, what's left is 2x, that goes here. And if I divide this out, what's left is the negative 8, and it goes here. There are your 2 factors. If I FOIL this out, 6x squared minus 24x plus 2x minus 8. So in fact, we'll equal this trinomial. Okay, so there's a lot to do there. You have to multiply the first and the last and use those factors to replace the middle term, and then do grouping. Group the first 2, take out a greatest common factor. Group the second 2, take out a greatest common factor. Okay, let's try it with this one. 3 times 4 gives me 12. Factors of 12. 1, 12. I don't even need to keep going. 3 times 4, 2 and 6, because negative 12 plus 1 is how I'm going to get negative 11. Again, I'm going to replace that middle term, just like we did over here. 3x squared plus x minus 12x minus 4. 4 terms, group the first 2, take out a greatest common factor. Both of those are divisible by x. Pull the x out. I get 3. You had 2 x's, you took 1 away, leaves you with 1. And anything divided by itself is equal to 1. So we have 3x plus 1 again. Same situation we were in this first problem where those terms are both negatives and I need them both to be positives. So I'm going to divide by negative 4. And again, my greatest common factor has to go in the front. And then in the parentheses, I tell what's left, 3x plus 1. Okay, so both of those terms have a 3x plus 1 in common. And if I were to remove it, we need to look at what's left. Okay, so left here is just x, and left here is just negative 4. And those are your 2 factors. Okay, so your job is going to be to flip the paper over and work on what you see as 15 sample problems, okay, on this page. First, I want you to figure out what kind of factor you're dealing with. So which of these do you have? Greatest common factor. Okay, so we're going to start here, always. And then you're going to, if there's 2 terms left, it's difference of 2 squares or it's nothing. So it's one or the other. And then over here, this is for 2 terms. If you have 3 terms, so if you have a trinomial, you're either going to do A as 1, where you're just going to slap them into the parentheses, or you're going to do where A is greater than 1, which is where you're using our grouping method. And you have the examples on the other side, so you can just take some time and use those examples as guides to help you with these, okay? So that's what you're going to be working on.